In this video, I'm going to introduce the Java technology. To put things in perspective, Java is the most widely used development language in the world today. Over 9 million developers report that they spend at least some of their time developing in Java, according to a recent Evans data study. And that's 9 million out of about 14 million developers worldwide. Not only do developers like Java, so do end users. According to Nielsen Online and Gartner, 1.1 billion desktops run Java. Between 2009 and 2010, there were 930 million downloads of the Java Runtime Environment, or JRE. The JRE is used by end users who wish to run Java applications. And during the same time period, there were 9.5 million downloads of the Java Development Kit, or JDK. The JDK is used by developers for Java software development. Java is everywhere. Today, all non-smartphones, commonly referred to as feature phones, run Java. 100% of Blu-ray players run Java. In addition, 71.2 million people connect to the web on a Java-powered device. 1.4 billion Java cards, a technology that securely runs Java on smart cards and other low-memory devices, are manufactured every year according to Instat 2010. This friendly-looking character reading up on his Java code is Duke, Java's mascot. The Java programming language was originally called Oak and appeared on the scene in 1991 as part of a research project to develop a programming language that would bridge the communication gap between consumer devices like VCRs and televisions. A team of skilled software developers at Sun Microsystems, known as the Green Team and under the leadership of James Gosling, wanted to create a programming language that allowed consumer devices that use different central processing units, or CPUs, to share the same software enhancements. The initial concept failed after several deals with consumer device companies proved unsuccessful. The Green Team was compelled to find another market for their new programming language. Fortunately, the World Wide Web was becoming popular, and the Green Team recognized that the Oak language was perfect for developing multimedia components that would enhance web pages. These small applications, called applets, became the first practical usage of Oak, and programmers who developed for the Internet quickly adopted what soon became the Java programming language. The turning point for Java came in 1995 when Netscape incorporated Java into its browser. Oracle provides a complete line of Java technology products, ranging from kits that create Java technology programs to emulation, that is, testing environments for consumer devices such as cellular phones. And you can see here, all Java technology products share the foundation of the Java language. Java technologies, such as the Java Virtual Machine, are included in different forms in 3 different groups of products, each designed to fulfill the needs of a particular target market. The figure illustrates the 3 Java technology product groups and their target device types. Each edition includes a Java Development Kit, or JDK, also known as a Software Development Kit, or SDK, that allows programmers to create, compile, and execute Java technology programs on a particular platform. The JavaFX API, or Application Programming Interface, is a rich client for creating user interfaces for your Java program. The MSA API is the mobile software application used to create user interfaces on portable devices. Applets and applications differ in several ways. Applets are launched inside a web browser, and applications are launched within an operating system as a standalone program. Most of the concepts surrounding Java application development can be applied to applet development. Java Platform Standard Edition, commonly referred to as Java SE, is used to develop applets and applications that run in web browsers and on desktop computers. For example, you could use the Java SE JDK to create a word processing program for a personal computer. NetBeans is a Java desktop application used for the development of Java applications, and it's an integrated development environment, or IDE, which means that it provides a comprehensive interface and all the necessary tools needed for developing in Java. Java Platform Enterprise Edition, commonly referred to as Java EE, is used to create large enterprise server-side and client-side distributed applications. For example, you can use the Java EE JDK to create an e-commerce application for a retail company's website. Java EE is built on top of the Java SE platform, extending it with additional application programming interfaces, or APIs, that support the needs of large-scale, high-performance enterprise software. The APIs are packaged and grouped to support different kinds of containers, such as a web container for web-based applications, a client container for thick clients, and the Enterprise Java Beans or EJB container to run workhorse Java components. Some of the kinds of functionality supported by the different APIs include objects, UI, integration, persistence, transactions, and security. Java Platform Micro Edition, commonly referred to as Java ME, is used to create applications for consumer devices that are constrained by the resources. For example, you can use the Java ME JDK to create a game that runs on a cellular phone. Blu-ray disc Java applications and Java TV use the same SDK as Java ME. Java Card is typically used for securing sensitive information that you'd normally find on a smart card, and these examples are only a small sampling of the power of Java Card. It can be used for things like identity, security, transactions, and mobile phone SIMs. In software development, we talk about the product lifecycle, the iterative cycle that defines an end-to-end process, beginning with conceiving your software and ending with the day your software isn't going to be developed or supported anymore. The first stage is analysis, which is the process of investigating a problem that you want to solve with your software product. Among other things, analysis consists of clearly defining the problem you want to solve, the market niche you want to fill, or the system you want to create. The boundary of a problem is also known as the scope of the project. Simply put, scope is the big picture that encompasses every aspect of the software you want to develop. You need to identify the key subcomponents of your overall product so you understand the needs of the project from beginning to end. Software developers and project managers are very aware that it's important to perform a thorough analysis of the problem. It leads to a good design of the solution and to decreased development and testing time. The design stage is the process of applying the findings you made during the analysis stage to the actual design of your product. The primary task during the design stage is to develop blueprints or specifications for the products or components in your system. The development stage is when we use the blueprints created during the design stage to create actual components. Once those components have been created, we need to test them. And the testing phase is the stage when we test to ensure that individual components and the product as a whole meet the requirements that we established for our software during the design phase. Testing is usually performed by a team of dedicated testers who weren't involved in the actual development of the product. This is because we want to ensure the product is tested objectively and without any bias. The implementation stage is when we deliver the software product and make it available to customers. Of course, this leads into the next stage, maintenance, because there are no testers quite as rigorous as end users. It's rare that any software is perfect at version 1.0, and it's inevitable that users will take your software product through the paces and discover things that weren't caught during development and testing. So the maintenance stage is when problems are fixed and the software is re-released, either in the form of patches for marginal bug fixes and other minor changes, and in the form of new versions when there are enough changes that a new version is merited. Finally, there's the end of life, the EOL stage. Although the product lifecycle doesn't have a separate stage for the commencement of a project, it does have a stage for the end of a project. EOL means carrying out all the necessary tasks to ensure that the customers and employees are aware that a product is no longer being sold and supported, and most commonly that a new product is available. The product lifecycle is an important part of product development because it helps ensure that products are created and delivered so that time to market is reduced, the quality of the product is high, and the return on investment is maximized, meaning that the project isn't only on time, but it's also on budget. Developers who do not follow the product lifecycle often encounter problems with the products that are not only costly to fix, but they could in fact have been avoided.